Hey everybody, welcome back to another fun and exciting algebra class. Today we'll be finishing up chapter number 11. You're almost done. Keep it up. Hang in there. One chapter left after you finish this one. Chapter 11, lesson 10 is about ratios, proportion, and work. All right. So, what did all these have? It's kind of like they didn't really have anywhere else to put them, so they just threw them right here. All right. So they are connected, but not connected at the same time. So ratios, proportions, and work. So what does work mean? Work means like when you work a job, how long does it take you to complete the job kind of thing. So look on page number 442. It's going to talk about ratios, proportions, and work. What does that mean? Well, ratios and proportions are connected, right? So ratios are fractions, proportions are equal fractions, fractions that compare numbers, but basically fractions. So then work, what is work? Work is like going to work, doing a job, completing a job, cleaning your house, manufacturing a car, whatever you're doing. You can use proportions ratios to calculate how much you're going to get done, what rate are you going to work at, like how fast are you going to work, what rate are you going to get paid at, things like that. So using these very important to understand for really life because you can use fractions, proportions to calculate different things, the speed at which something's going to happen, how long it's going to take you to complete a task, things like that. All right, look down here at the screen. You can look in your book as well. This is example 11.10a. The example says that the sum of a fraction and its reciprocal is 26 over 5. What is the fraction? Well, let's just go ahead and let's write an equation. It's algebra class, right? So that's what we do. We write equations. So notice that we see the word sum. That should be a keyword. There's going to be an addition. We see the keyword is. There's going to be an equals, okay? This is the equals because it's the only thing on the other side. So 26 over 5. Now, what's being added together? A fraction and its reciprocal. What is the fraction? Well, that's what we don't know. Well, what do we do when we don't know? We write x. What is the reciprocal of x? Well, remember, it's x over 1, right? So the reciprocal is 1 over x. Okay? And so there we go. We have it into our equation. Now we just start solving it. Again, how do you solve? You try to combine these two things. Can we combine these? Well, no, not really. One way to get rid of the fraction, this is what I would do. There's other ways to solve this, but one way to get rid of the fraction is to multiply by the least common denominator. What's our LCD if we make that a fraction? So our LCD is going to be 5 for the numbers, because 1, and that's got a 1 in front of it. So 5 for the numbers, and then x. LCD is 5x. So if we multiply everything by 5x, that's going to cancel our fractions. So let's just go through and do that. What is 5x? These are all fractions, right? So can't really do anything, so that's going to give you 5x squared. 5x squared plus x's are going to cancel here, and we're going to get 5 times 1. We're going to get 5, and that's going to equal, and the 5's are going to cancel here, and we're going to get 26x. Now what you need to do is just continue to solve it. This looks like it's probably going to be a quadratic, right? So we're just going to subtract 26 from both sides. We're going to get 5x squared minus 26x plus 5 equals 0. Why did I do that? Because I put it in my standard form, right? I put my quadratic term first, my linear term second, and then my constant term third, and I set it equal to 0. Just when I moved it over there, that's what ended up happening. Because now I can factor it. That's what I want to do, is I want to try to get a solution. And in this case, we're going to get 2 answers, right? So we're going to get an x and an x. We can look at kind of our signs here, and what's going to happen is we're going to get a minus minus out of our signs. Our 5, so one of these is going to be a 1x, and one of these is actually going to be a 5x. Let's give some more room there. So we'll make a 5x, and then this is going to factor out to a 1 and 5 as well. So one of these is going to be 1, one of those is going to be a 5. I don't know if that's going to work or not. We have to FOIL it to see. We really only need to do the outers and the inners. And so the outers are going to give us minus 5x, and then the inners are also going to give us minus 5x. That only equals negative 10x. We need to get to negative 26x, so that's not going to work. So let's kind of go back here and let's figure out what could we do differently. Let's try to swap the 5 and the 1 right there and see what happens. So we'll go a 5 and a 1 like this. And so we'll multiply there and we'll get negative 1x. And we'll multiply there and we'll get negative 25x. This looks better. Add those together, negative 26x. Okay, good. That worked. So that is our solution. X minus 5, 5x minus 1. Okay, notice that we have it set equal to 0, right? So we have to do that again to each one of these. Equals 0, 5x minus 1 equals 0. Solve these. Add 5 to both sides. That's going to be x equals 5, positive 5. Over here, we're going to move the 1 to the other side, and we're going to get 5x equals 1. Divide both sides by 5. That will give us x equals 1 over 5. So there's our two solutions. We're going to get x equals 5 and x equals 1 out of 1 over 5. So what's going on here? What's happening? Let's go back to the original question. The original question was the sum of a fraction and its reciprocal is 26 over 5. What is the fraction? So in this case, what we have is that the fraction could be, theoretically, the fraction could be 5 over 1, or the fraction could be 1 over 5. It's going to give us the same answer. I mean, I would probably pick that one because that's a fraction. But, I mean, technically 5 over 1 is a fraction as well. So the reason we did that in this lesson is we just wanted to kind of practice with fractions a little bit, practice with reciprocals a little bit, practice with word problems a little bit, plugging things in. So next, let's find the rate. What is the rate? The rate is the speed at which something occurs. How fast is it happening? Compound rate problem. So now we have two different people doing a job, two different people driving a train. You've seen those types of problems, things like that. So we have a compound problem. Here's the way that you solve these for the most part. Time worked of A, with person A, and the rate worked of person A, plus the time worked of person B times the rate of person B, and that's going to equal the total of whatever is being done. Okay, in this first problem, there's a house being cleaned. Maybe they're making cars, maybe they're making cookies. I don't know what they're doing, but every problem is going to be different. All right, so let's think about this and let's kind of put this into this problem. So Allison cleans her grandmother's house in 4 hours. Let's kind of set this up. What's the total? Well, the total is like one house, right? One house is being cleaned. No matter which person is cleaning it, they're still cleaning the same one house. So if we look down here, we'll say, okay, how long will it take them? That's what we're looking for. So that's what we want to know. We want to know the time worked, right? So we're looking for the time. I'm going to call that T, capital T, because this plus sign is going to look like a small t if I do it. And so then we also have a time over here of the sister, Erin. So this is the time and the time of the two different sisters. What's the rate of A? Well, the rate of Allison is that she cleans in 4 hours. So 1 over 4 is her rate because she basically, if you think about it, like she cleans 1/4 of the house in an hour. If we kind of make it, if we simplify it out to how much does she get done in 1 hour, she cleans 1/4 of the house in an hour. and the sister cleans 1/6 of the house in an hour because it takes her 6. Now, there's other ways that you could set this up, but this is just one way. This is the way that the book shows you to do it. So what we want to do is we want to take these two things and we want to add them up. And one way that maybe you could speed this up, adding 1/6 and 1/4, you're like, I don't like fractions. Okay, well, get rid of the fractions. Multiply by the least common denominator, which is what goes into, what do these both go into? Well, they both go into 12. So you can multiply everything by 12. And that's kind of why we practiced that one before. And what happens when you do this is you get a cancel here, and you get 3t plus cancel here, 2t equals 12. 12 houses? No, we'll get rid of the houses. 12. I mean, technically it is 12 houses at this point because we got rid of our fractions. So now you would just add these together. I'll kind of skip down here. So 3t plus 2t is going to be 5t equals 12. Divide both by 5, and we're going to get our time is going to be 12 over 5, which is going to reduce down to, you divide that out, 12, 5 goes into that 2 times, 10 and 2/5. So our time is going to equal 2 hours and 2/5 of an hour. You could do that out. You could put it in a decimal if you want. So that equals 2.4. You could figure what that is in minutes if you want. But 2 hours and 0.4 of an hour, which, what is 0.4 of an hour? The one way that you could do that is 2 over 5 equals x over 60. So to do that, you would just multiply here. You get 120 divided by 5, and that gives you 2, 10 to 20, 24 minutes. So that would be 2 hours and 24 minutes is how long it would take them to clean the house together. All right, notice on page 444, we can also do this when you have like portions of things happening. So somebody's working like a little bit without the other person. For example, Mr. Calhoun can roof a house in 5 days. His son can do the same in 7 days. If Mr. Calhoun works 1 day by himself on a job and then is joined by his son, how long will it take to roof the house? So we basically set it up the same way. Mr. Calhoun would be A, and so he would be 1/5, and then the son, so 1/5 t, and the son is 1/7 t. And you know, we're building one house, we're roofing one house. But here's the problem, here's the difference. When we do it by the t, you might say, no, their time was not the same, and you're right. It would be t minus 1 day, right? Don't forget that he worked 1 day by himself. So this is the son. The son worked 1 less day, minus 1 day. And this would be, we'll just add that together. Okay? And I think what I would do here is I would distribute this 1/7 in here. You can do it a number of different ways, but I would get 1/5 t plus 1/7 t minus 1/7 equals 1. Now I would get rid of my denominator by multiplying everything by the LCD. And the LCD in this case of 5 and 7 is going to be 35. So we're going to multiply 35 everywhere. Yeah, you have to multiply it by everything. You can't just multiply it by one thing. Make sure you don't skip anything. There are 4 things to multiply that by in this problem. Here we're going to get a cancel. We're going to get a 7. 7 times 1, that's a 7t now. And that may make it a capital T. Plus, this is going to cancel here to a 1. That'll cancel to a 5. This is going to be now a 5t. And then we have a cancel here of 1, a cancel here of 5. That's going to be minus 5 equals 1 times 35 is 35. And now we'll just go ahead and move the 5 over to the other side, add 5 to both sides. and we can combine this. So we're going to get 12t equals 40. And then we would divide both by 12, and this is going to give us our t equals. What is the time that it will take both of them? 40 divided by 12, add your zeros. That goes in there 3 times, so 36, 4, and it just keeps repeating, 3.33333. And so it takes 3 hours and a third. And that would be the answer. You could put that in minutes, just like I put the last one in minutes, but that is how you would solve that question. All right, I know there's a little bit more to this, but this is already a long lesson, so I'm going to cut it right there and do a B section to this lesson as well. And so make sure you watch that. It's about proportions and how to do things using proportions. I know it's complicated stuff, but make sure you go back, watch that video again, look at the the illustrations there in your book. That way you can kind of solve through it. Practice some of these. Go to the practice problems. Rewind the video as I'm doing it. Try to work your practice problem along with me. Make sure that you're getting those things subbed in there best you can, and then just work your equations. Okay? That's all I got for you in this lesson. We'll see you later. Have a good one. Bye-bye.